Hello, I am Dinakar Raj. My roll number 20951 A0442 and I am from ECE C section branch. Subject electromagnetic waves and transmission lines, and in this subject my topic is correlation between electrical accident and parameters and injury. This is my topic. So in this topic, first of all, what are the electrical injuries? So first of all, we are going to know about what are the electrical injuries. There are four main types of electrical injuries. They are flash, flame, lightning and true. So these are the major four types of electrical injuries. So in this, flash injuries caused by an arc flash are typically associated with superficial burns, has no electrical current travels past the skin. So this is about flash and injuries. And what causes electrical injury? Electrical injury can be caused by accident contact with power outlets, power cords, or exposed parts of electrical appliances or wiring. Flashing of electric arcs from high voltage power lines, lightning. What is electrical accident? An electrical accident is an undesired event caused by electrical current resulting to injury to a person or damage to property. An incident is an undesirable event where an electrical current could have led to injury of a person or damage to property. What are the main causes of electrical accident? Typically, electrical accidents are caused by water, faulty wiring, attempting to fix electrical yourself, naked cords and damaged plugs. So let's take a closer look at each of these and how they occur. Electricity and electrical injuries 1.6 by 7.3, that equals to 22%. Charge coulombs, current amperes, EMF volts, resistance Ohm's law sources and load AC versus DC needed to know a few terms. Item measured in 1 coulomb equals to charge of 6.21241509 into 1018 electron charger. 1 electron equals to 1.6021767 into 10 to the minus 19 coulombs. Quantity of electron charge minus coulomb. Flow rate of elementary charged particles measured in amperes. Electric current 1 amperes equals to 1 coulomb per second. Current is an rate function. EMF and volts. An EMF makes the current flow measured in volts. 1 volt equals to 1 joule per coulomb energy required to move unit charge at infinity to a point. Ohm's law equals to R equals to V by I. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. 1 ohms equals to 1 volt by 1 ampere. Volts equals to joule per coulomb. Amperes equals to coulomb per seconds. V into I equals to joule per seconds. Watts power. Energy square of voltage or current directly proportional to power, that equals to V into I, that equals to 1. Dimension manipulations Power for t seconds. Energy 1000 watts for 1 hour. 1 kilowatts 25 cents. Resistance of body, tissues, nerves, blood, mucous membranes, muscle, dry skin, tendon, fat, bone. Maximum safe current tolerable for 1 second equals to 50 milliamperes. Source load electric current seeks its source active neutral power lines. Active burn neutral blue earth green, yellow plug active right plug, ARP socket active left socket, ALS alteration, flex wiring, colors wiring, alternating current time direction amplitude. Electrons does not flow unless they are pushed or plugged. The force that moves them is called an EMF and is measured in volts. The formal definition of a volt comes from electrostatics and the electric field that charges produce which extend outwards to infinity. The analogy is a gravitational field. Imagine that where I am standing there is a negative electric field and sitting out at infinity there is a negative coulomb of charge feeling the push. To make the charge at infinity move to me it takes energy. You are pushing against the field like lifting the weight. If it takes 1 joule to move that 1 coulomb, then the point in space you are measuring has a potential of 1 volt. A volt is a joule per coulomb. Since currents flow between points, what if more useful that potential is difference in potential. In fact, voltage has come to mean the same thing as a difference in potential. It's the difference in potential that makes it happen, like dropping the weight in the RHS of this slide. Thank you. Electricity is generated by the flow of electrons across a potential gradient from high to low concentration through a conductive material. The volume of electrons flowing across the potential gradient is the current, which is measured in amperes I. A 600 volts current can cause significant tissue damage and death. In the literature, versilimitated lightning is neither a direct current nor an alternating current. At best, it is a under unidirectional massive current impulse. Frequency psychological changes, thermal injury. Electrical injuries, AC more dangerous than DC. One jolt often throwing victim of high voltage 1000 watts more dangerous. Thermal injury, coagulation, uh, necrosis 50 watts safe. No deaths recorded from retulation or telephone wire survival. Planet 3 neutral active 240 by 1000. To make the charge at infinity move to me, it takes energy. You are pushing against the field, like lifting a weight. If it takes 1 joule to move that 1 coulomb, then the point in space you are measuring has a potential of 1 volt. A volt is a joule per coulomb. Since currents flow between points, what is more useful that potential is difference in potential. In fact, voltage has come to mean the same thing has a difference in potential. It's the difference in potential that makes it happens. The formal definition of a volt comes from electrostatics and the electric field that charge produce which extend outwards to infinity. The analogy is a gravitational field. Imagine that where I am standing there is a negative electric field and sitting out at infinity there is a negative coulomb of charge feeling the push. Thank you.